Sea levels are rising. Okay, bummer. That sucks. Unless you live at high elevation, in which case your not beachfront property will eventually become beachfront property, which I guess is bright side of that. However, we see that water levels rise because ice that's not in the ocean melts and water in the ocean and it comes up. Why else would water rise? In general, with most things, as you heat it up, what happens with its volume? It expands. Is water something? So when you heat up water, what do you assume happens with its volume? So it's not huge and like a small cup of water or anything, right? You're not going to see a noticeable difference in volume of a cup of water. But when you have trillions and trillions and trillions of gallons of water that all increase a little bit, that's going to add up eventually. So we'll make a few smaller points here. Sea levels are rising, not only from melting, and we'll just say here underneath. This is resulting from two things. First is melting ice. And beyond that, we have that fancy idea of water takes up more space when it warms up. This has its own name, thermal expansion. Now, currently, with the sea level rise that we are seeing on our planet and that we have seen over the past several decades, what we have right now is roughly the amount of sea level rise that we've gone through. Huggins, let me take out the hat. The amount of sea level rise that we've gone through is about 50% due to this. Do you need lead or a pencil? Okay. 50% right now is due to thermal expansion, which kind of a big idea. Now, there are other places that happen. Right now, if you've ever gone out and had a nice day in the snow and you don't wear sunglasses, you run the risk of going snowblind. If you've ever gone skiing or cross country, like out, snowblind. Because what color reflects light really well? White. Black absorbs light really well. Okay, if the whole ground is white, all the light that's coming off isn't getting absorbed and turning into heat there, right? It's reflecting off of us. So if we lose a bunch of ice on our land, all that light energy that would have reflected out and never been changed directly into heat now strikes the land and it changes to what? It doesn't reflect, it just changes to heat right away. So we have this bigger issue. Now, as we look at this, this has a name. Not only does melting ice and thermal expansion lead to sea levels rising, lead to high water levels. I'm going to say high water. But beyond that, we get another impact of this ice melting. More ground is exposed, less light is reflected, which means more heat is absorbed. We see a decrease, and I'm going to write this nicer. Less ice leads us to less light reflected. Now, that is the nice way to say this, as opposed to saying less light reflected, the alternative that I'm not going to write here, but we just spoke about it. Less light reflecting means more what is being absorbed? Heat is what's the culprit here. Now, it turns out is that we see changes in what's called albedo, which is just the reflectivity of Earth's surface. Okay, decreases in reflectivity mean increases in absorption of heat. All right, now, beyond this, we have a lot of ice up north and down south, but not so much near the equator, which means bigger changes are happening near the poles. Like no more energy other than the fact that less ice means more energy gets absorbed. And by virtue of that, we're seeing temperatures rise both in the North Arctic and the Antarctic twice as fast as everywhere else in the world on average. Okay, beyond that, just to put that into perspective here, we get bigger changes that happen. Glaciers, freshwater or saltwater? Fresh. Saltwater doesn't freeze. The salt precipitates, it falls out of it. Okay, so we get a lot of fresh water that goes into our ocean, right? Which means now we have lower overall salt content, which salt affects the density, and the heavier the water, the further down it sinks. It works its way around the Atlantic, and it normalizes our global climate. That's the Great Ocean Conveyor. When we introduce way more fresh water into our ocean because fresh water is pouring in, is that going to impact the density and in turn the Great Conveyor? Absolutely. We're leading to possible terrible, terrible changes. But again, I just want to stress with all of this because it's super negative. I think humans are going to figure it out. I really do. Okay. For this, 3 millimeters per year, we're at what elevation currently right now?
Us right now?
Yeah, currently. What is your elevation?
Pretty much zero.
So pretty much or a little bit above 0?
Just a little bit.
We're like 2 or 3 meters currently, right this second, which means we got a lot of time before the school is in the ocean. Like, swells might push some of the ocean into the school, but not while we're here. Okay, beyond that, this is going to impact a lot of life on the planet. It's going to impact anything that lives in the ocean because temperatures are changing, densities are changing, concentrations of salt are changing, so forth and so on. How many people are on our planet? 8 billion. I think we're probably closing to 9, pushing to 9 soonish. I don't know when that'll exactly happen. A lot. Okay. What percentage of humans do you think live on a coast?
Like on a cruise?
So 1 billion out of the 8 billion, so roughly 16%-ish. That's a reasonable guess. A little low. You were too high. We're going to meet in the middle. About 40% of all humans live on coastline. 40% of 8 billion, so like 3.5 billion people impacted by this in the coming century or centuries. Cool. Not cool. That's just my transition. I don't think climate change is cool. Some places. All right. Anyway. So I'm trying to not write a crazy amount. Why 10 years ago, 15 years ago, seemingly the whole language that we used about the changing climate switched. It wasn't always called climate change. When I was maybe your age or on my 40th birthday, whenever, depending on how old you think I am, I don't know. What did we used to call it?
Global warming.
Global warming. Now, theoretically, if we're just adding a bunch of greenhouse gases, it seems reasonable that the whole planet would warm up, right? However, all these little changes as they compound into the great ocean conveyor and our climate models and everything shifts, it makes sense, I think, and I argue, that some places get warmer. Cool. But not everywhere gets warmer all the time because these shifting weather patterns might make it so cold air winds up new places which cool down. The entire planet, on average, is warming. That is happening. But it's super misleading when we word it as global warming. The climate is changing. That's where we make that switch. Cool. Now, when we think about this, I don't know about you, who's the main character in your story that you're living?
What?
Who's the main character in Jamin's story? Your life that you're living?
Stonewall?
That's a weird answer. Congratulations. I think you might get 2 of them. I think about you guys a lot, just so you know. I think about my wife, my family. Who do I think about more than any of you? Obviously, me. I'm the best. And you should all feel that you're the best as well. You're your main character. Preferably the hero instead, but to each their own. As we look at this, we would be leaving out a huge negative thought here, but we need to think about the impact on humans. Like, I can handle, personally, if the average temperature in Alaska went up 3 degrees Celsius, I don't have a huge issue with it. Like, my house gets maybe uncomfortably hot sometimes, but no major change, right? Okay, so when we talk about the impact on humans, it's not the direct, just temperatures increasing. Okay, what sort of impacts on people can we come up with? Rather than me just writing a bunch here, I'm going to give you guys like 90 seconds. How are people going to be impacted by a changing climate? Cool. 90 seconds, talk it out. Get loud, get crazy. Discussion about this. All right, give me an example that you guys came up with. How are people going to be impacted? Food. Why? Why would food? So you're thinking about the ocean. Okay, so global ocean temperatures might change, right? Like, we talked about this last class. If there are fish that live in a particular temperature range and the temperature changes, they're going to do one of 2 things. They're going to die, or they're going to go to where that temperature is, and now we can't catch them anymore. Okay, so certainly that. Cool, and I'll write down a few things. Another one.
Like plants.
What about them?
Like it's like the same thing as fish. Like a lot of them have to like live in a certain environment.
Yeah, absolutely. Now, if we even expand, like your guys are both right. If plants and agriculture specifically, like we need a few things for good plant growth, right? We need good temperatures, we need good water, and we need good soil. Like those are the main ideas. Now, on one side, more CO2 in our atmosphere is good for plants, just to throw that out there. Like the plants love it. However, if all these changes compound and start to act together in unison, and all of a sudden our weather patterns change. This happened in the 30s, I believe, or the 20s in the bread bowl of the U.S.
Yeah.
What happens when the food crops don't get water? They turn to dust. And what do the people eat? Yeah, they can try. I mean, they might eat dust. That'd be a weird thing to do. They don't, realistically, right? Like, people starve, and you get mass famine, which is a bummer. But looking at these, we're going to list just a few of them. Any others that people came up with? So food, quality, and resource, definitely. Other issues. What was the biggest hurricane on record, the most expensive? Katrina. Now, I didn't go crazy into detail. Do you guys know why Katrina was so crazy expensive? There were levees in New Orleans. New Orleans is below sea level. I'm just going to turn that alarm off. New Orleans is below sea level, and they have little dams to block it. But you get a big old storm that comes in, and the Army Corps of Engineers that didn't have the funding to like replace and fix those things, if the levees break, all the water comes, and you flood an entire city of millions of people. Huge issue in that regard. Okay.
Is that what happened?
That is exactly what happened. Yep. They tried to pawn it off on the Army Corps of Engineers. It's everybody's fault for really. There should have been funding for it.
What's the Army Corps of Engineers?
So it is a branch of the Army of Engineers. And I know that sounds dumb. Like, they're the civil engineers that will go through and do big projects like that. So if you need a big seawall, like in Seattle, for example, they rebuilt the seawall. That's probably the Army Corps of Engineers that's working with it. Okay, so looking at this, we are getting more hurricanes and stronger hurricanes every single year. It's happening. So one major impact that I think is worth highlighting, and this will hit a few of them, we're going to get bigger, stronger storms. Now, these come in all the terrible flavors. It could be hurricanes, they could be tornadoes, they could be droughts. All of these things play on each other. Bigger storms. Okay, beyond that, some places will also experience higher temperatures. Now, again, a single degree won't impact one particular person, but if you think about big crop areas, if higher temperatures in one place indicate lower temperatures somewhere else, and there's a frost line where crops die off because, the infrastructure to cover them isn't there, that's a huge issue as well, whether they increase or decrease in a particular region. Okay, higher temperature and bigger storms mean that air must be traveling a little bit differently, right? Which means the rainfall patterns, where rain falls, is now a little bit different. So we see increased or change in rainfall. This one is what Harbor, I believe, brought up, plants. If all of a sudden the Midwest can't grow crops because they don't get as much rain to support those crops, where are they going to grow them? Where do we have the infrastructure to just pick up all of our cropland and put it down somewhere else? We don't really yet, right? Now, we will, because we'll have to, but that change in rainfall is certainly impactful on the crops as well. As a further little piece of this, California right now, they ration water or no? I don't know if you guys know that. California is in a drought. Is that true?
That's also true, but Arizona is too. Arizona has to get all their water from other states.
Yep, I have huge issues with Phoenix, just because of that. Like, you've probably heard. Have I complained about it to you guys before? Oh gosh, Phoenix. Anyway, beyond that, changes in rainfall can certainly impact crops, right? That makes sense. But what do you need? There's a rule of threes. 3 minutes you can live without what? Air. You can go 3 minutes roughly, the average person, without air. How long can you go without water? 3 days. How long can you go without food?
3 weeks.
3 weeks, as a rule of thumb. Now, with that, if places like Phoenix or LA, wherever, they rely on snowmelt and rainfall that's collected, and they distribute that for water. Okay, if it stops raining in Southern California, then you have 10 million people in LA, you have 10 million people in Phoenix, and all those other cities, water production is gone, and all of a sudden, without water, it goes insane. Okay, gentlemen, please don't make me talk over you. Okay, beyond that, water shortages. This impacts shortages with crops, all of that. Okay, shortage. Crops, those are 2 places. Okay, if we look at just this water with less snowpack, crops. That looks like a question mark. It's odd. Weird. My handwriting gets worse throughout the day. Roughly right now, if we look at the places in the world where water, access to good, clean water is an issue, like in our country, it's not a huge issue in most places. We're impacting anywhere between 1 and 4 billion people. So you tack that on with the 40% of people, which is at 4 billion from the coast. Some of them, of course, overlap. This is going to impact like 6 billion people on our planet, which is huge that we're not making big strides to try to correct it. Don't know that we could, yet. I think we will. Okay, beyond that, impacts on humans certainly worth mentioning. We also talked about fish and game populations. Okay, I'm going to just, without writing it again, this is encompassing all of agriculture as well. I know it's not wild game, but we're just going to count it. Okay. In specific marine ecosystems, because we're fishery science, we are looking at the impact here. Okay.
Maybe that's why our food type.
So we actually have, you want an update on the fish? Oh my gosh, I just turned it off. No, I didn't. I snoozed it. Do we let it go 5 more minutes, or do I actually turn it off this time?
5 more minutes.
Double it and give it to the next guy? All right, cool. So, marine ecosystems. We talked about this one day a few weeks ago, right? If you want to see something real spectacular on our planet, you might go where? And what might you see in Australia?
Oh, the Great Barrier.
The Great Barrier Reef. Now, it's a huge, huge bummer. But remember, or I'm pretty sure it's this class, I'm covering the same thing like 4 classes, so it's easy to get mixed up. Water falls through the air, I think. That sound right? Okay, water falls through air. And air has more CO2. And when water adds with CO2, you get a carbonic acid is what it's called. Really not a crazy acid, but an acid nonetheless. Now, as we look at this, we see this being impacted already. Coral reefs are being bleached and they're starting to disappear. Not all of them. The Great Barrier is one where there's huge swaths of coral reef that are dead at this point in time. And it's a huge bummer. Not everything is going to struggle though, right? What's bad for some is going to be great for others. This is the big one. Migrations are another issue that we might encounter. If it stops snowing in southeast or even here, it means this river doesn't run. And when that river doesn't run, what else doesn't run? Water. And when the water doesn't run, what doesn't run up the river? Fish. And all of a sudden we have a huge issue there, right? Because they can't run, they can't, like, that whole ecosystem's gone. All right. Everybody nice and bummed out?
Yep.
Bummer. Sorry, that was not my intent. Okay, I'm trying to go through relatively quick. Okay, not the happiest moment. For today, I try not to do this. For now, I'll put a few questions up here. We're going to take 5 or 10 minutes, and I want you guys, using your notes or the text that's in your book or the book next to you, or the desk next to you, sorry, I want you to knock out these 3 questions for me real quick.
Write it
On a piece of paper.
on.
Yes, you're going to hand it to me. Cool. Sweet, I will pause this.
We don't take it